So today we're going to be doing the column where we're starting from 96 to 98. This is going to be a quick section because we only have a few questions, so let's go ahead and jump into it. For 96, we're going to choose the equation that represents each of these graphs below. So we have 4 different graphs, A, B, C, and D, and we have 6 possible equations. So we could either A, deduce both the sine and cosine of each of these graphs and figure out what those equations could be and match them up, or we could graph each of these equations and match those graphs with our predicted graphs. Because every single one of our possibilities is cosine, I think the best way to do this is to come up with the equation for cosine for each one of these graphs. So without further ado, let's jump into A, and we're going to create the equation for A given what we see. So let's see, 96A. Okay, so I need a few things to answer this graph. I need to find out what the amplitude is, which will give us our first variable. I need to figure out what the phase shift is. I need to figure out what the vertical shift is. And I need to figure out what the period is. With these 4 things, I can create an equation. Now, the amplitude is similar to any other equation. I need to figure out how much it's been stretched. So I'm going to find the midline. I notice I go up 2 and down 2, so I know the midline is 0, which means the amplitude goes up and down by 2. So I have an amplitude of 2. That also lets me know that because it hasn't shifted up or down, the vertical shift is 0. The phase shift is how far left or right the graph is moved. Now we know cosine always starts at a peak, and because this graph starts exactly at a peak, I know there's a phase shift of 0. The last thing we need to find is the period. The period is going to tell me the factor that's multiplied by x, which means how far the graph has been stretched like this. We see the fact that this graph and this graph, this has a smaller period. It repeats itself much more often. By the end of the graph, I've gone 2 times. By the end of this graph, I've only gone once. So this has a smaller period, this has a larger period. Okay, so what is the period and how do we find it? So to find the period, I need to figure out from peak to peak, how far is that distance? And I have a distance of 1, 2, 3, 4. And so with this information, I can create an equation. So for this, we know that the equation is going to be y equals a cosine of bx plus or minus, we'll call it c plus or minus d. And so let's plug in the information we know into this set of equations. A is going to be our amplitude, how far the graph moves up or down, so I know it's going to be y equals 2 cosine. The bx, the b is going to be the constant or the coefficient that determines our period. So I have to do a little bit of side work to figure out what that b term is. I know 2 pi divided by b will give me the actual period. And actually, let's pause here real quick before we continue with this mistake. We know that domain increments are in pi over 2. So it's not a period of 4, it's pi over 2, pi, 3 pi over 2, 2 pi. So let's actually scratch this out and say the period is 2 pi. Okay, so I know that 2 pi divided by whatever number I have here will give me my period of 2 pi. In this case, I just work this equation and solve for b so I can plug that in. So I'm going to cross multiply and say 2 pi equals 2 pi b. Divide both sides by 2 pi and I get b is equal to 1. So I'm going to use that information to plug it into here. If I have the cosine of 1x, I'm just going to write as the cosine of x. This is going to be my phase shift, which is 0, so I don't put anything. This is my vertical shift, which is 0, so that's it. So A is going to be this equation, which let's take a look and see, okay, y equals 2 cosine x. I know that that is going to be that equation. Okay. If I move off to my part B, let's do this right below that. So for B, again, I need those 4 things. I need the amplitude, I need the phase shift, I need the vertical shift, and I need the period. Okay. The amplitude, if I'm looking at it, it looks like it goes up 1 and down 1, which means the amplitude only goes by 1. The phase shift is how far left or right. Cosine always starts at a peak. That starts at a peak, so it hasn't moved left or right. The vertical shift is that midline. Has that moved up or down? No, we know the midline is right through the center of the graph still, so that vertical shift is still 0. And the period is how long for the graph to repeat itself. I go from peak to peak, from here to here, so it's pi over 2, 2 pi over 2, or just pi. Okay, so that's all the information we need to solve for b. I know it's going to be y equals a cosine of bx plus or minus c plus or minus d. Okay. For my first step, I know my amplitude is going to be 1. Typically, we don't write the 1, so I'm just going to write cosine. To figure out the b, again, I know to figure out b, normally to find the period, I say 2 pi divided by b is the period, which in this case, 2 pi divided by b is pi. Cross multiply. b pi is 2 pi. Divide both sides by pi. b is 2. So I have cosine of 2x. To find that left or right shift, I go with the phase shift, which doesn't exist. The vertical shift doesn't exist. So I get this equation, which we know is unique from this equation up here, and I want to check my bank to make sure that that does exist on there. Cosine of 2 pi, or cosine of 2x, sorry. Yep, so there we go. We've got b. Let's take a look at c. I know the 4 things I'll need are amplitude, phase shift, vertical shift, and the period. So for part C, let's take a look. To find the amplitude, I go how far up or down. So the total distance from 0 to -2 is a distance of 2 units. I cut that in half. That means the middle line goes up 1, down 1, up 1, down 1. So the amplitude is 1. The phase shift is how far left or right the graph has moved. It should always start at a peak. This is starting at a peak, so the phase shift is 0. The vertical shift is how far the graph has moved up or down. I notice we just said the middle of this line, or the middle of this wave, is right here because it goes up 1, down 1, up 1, down 1. So the vertical shift has actually been moved down by 1 unit. The period, we count how long it takes for the graph to repeat itself. It goes from here to here. So pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, which reduces down to 2 pi. That's all the information we need to graph this. Y equals a cosine of bx plus or minus c plus or minus d. Okay. For this one, the amplitude is going to be 1, so I don't need to write that. Y equals cosine. For the b, I need to use this again, so I'm going to come over to the side and say, well, 2 pi divided by b is the period. So 2 pi divided by b is 2 pi. Cross multiply, 2 pi b is 2 pi. Divided by 2 pi, b is equal to 1. Okay. So I'm going to write this as cosine of x. I have no phase shift left to right, so that doesn't exist. But I do have a vertical shift of down 1, which means that pops up as a -1. We notice that happens outside the parentheses. Inside is where we move left or right. Outside is where we move up and down. So I'm going to check that against my list of equations, and I do have that. So far I've used the top 2 and the middle right. Awesome. So now let's switch over to the last graph, which is D. I don't know why I did this one lowercase and the rest were uppercase, but oh well. We need to find 4 things: the phase shift, the vertical shift, the amplitude, and the period. Okay. So the amplitude is how far up or down it goes. I notice that it goes to a maximum height of 2 and a minimum of 0. which means the middle is going up 1, down 1, up 1, down 1. That means that the vertical shift, if I notice that it's going up 1 and down 1 and it never goes below the graph, that middle of the graph is going to be at 1. So that vertical shift is up 1. Phase shift is how far left or right. It should always start at a peak. So there's no phase shift. And the period is how long it takes to repeat itself. So from here to here, the graph completely repeats itself. That's going to be pi over 2 and 2 pi over 2. 2 pi over 2 reduces down to pi. Okay. That's all the information we need to graph or come up with the equation. Y equals a cosine of bx plus or minus c plus or minus d. My amplitude is 1, so I don't need to write that. My b I do need to figure out. 2 pi divided by b is my period. So 2 pi divided by b is going to result in pi. Cross multiply. Pi b equals 2 pi. Divide by pi, b equals 2. So I have 2x. I don't have a phase shift to the left or right, so I close it. I do have a vertical shift of up 1. I come over here and I check my list of possible answers, and yes, I do have this. So I used the top 2, the middle right, and the bottom left. Okay. Let's move on to question 97. Okay, so let's slide this over. For question 97 and 98, we're going to use this table. Okay. So we have a math teacher keeping track of students who enter their class on test day and whether or not they bring a calculator. The results are shown below. 9th grade students, I have those who did and those who did not bring a calculator. 10th, I have those who did and those who did not. So I could figure out that it looks like I have 29 9th graders and 15 10th graders. Or if I look at it horizontally, I have 20 students who did bring a calculator and 24 who did not. So I've got a class size of, 44 students. That's a big class. So for 97, we're going to figure out what is the approximate probability that a 10th grader brought a calculator, and write your answer as a decimal. Okay? So there's a couple ways to solve this. We could use just the intuitive approach. What is the probability that a 10th grader brought a calculator? We could say, out of the 10th graders, how many brought a calculator? Which is going to be, out of all the 10th graders, I have 15 students. So my probability is going to be out of 15. Of those 15 students, I had 6 bring a calculator. So it's going to be 6 out of 15. So that probability is going to be whatever 6 divided by 15 is. So 6 divided by 15 gives me 0.4. 0.4, which is 40%. Awesome. And now, one of the things that you may want to do is you may want to add it all up and say, well, it's 6 students out of 44 students. Remember, the question is not asking what is the probability that there is a student who is both a 10th grader and brought a calculator. We're saying out of the 10th grade students, how many brought a calculator? So 6 out of those 15. Another way you could look at it is you could look at the fact that we do have an equation that is given to us right here. The probability of B given A, I could write it like this, the probability of B given A. And I could figure it out a second time in a second way. Okay. So the probability of calculator given that they are a 10th grader. So that would mean I need the probability that they are both a calculator student and a 10th grade student given, oh, sorry, that should be backwards. Probability given A, probability given that they are a 10th grader. So if I look at this, let's see if our numbers compare. The probability of a calculator and a 10th grade student, okay, so calculator and a 10th grade student is going to be 6 out of, we said it was 44, 20 and 24, divided by the probability that they are a 10th grade student. So the 10th grade student is 15 out of 44. If I were to work this equation, I know I'm going to keep, change, flip. This is equal to 6 over 44 times 44 over 15, which is, we know those 44s cancel out. We're left with 6 over 15, which is, again, 40%. Okay, so you could use a formula, or we could just use an intuitive approach right here. They both work out. So that is question 97. Question 98, what is the approximate probability that a student who did not bring a calculator is a 9th grader? So out of the students who did not bring a calculator, what's the probability that they are a 9th grader? So what I'm going to do is I'm going to say the probability, what is the probability that a student who did not bring a calculator, so did not bring, I have 15 and 9, the probability that out of them, which is out of 24 students, that they are a 9th grader. So out of the ones who did not bring, I have 15. So 15 out of 24 is going to be equal to 0.625, which is equal to 62.5%. Awesome. And that's it.